and there are two branches which are coming out from this root node. One is labeled by yes, another is labeled by no. That means we have two different choices. Okay, if we choose the branch labeled by no, then we cannot solve. Okay, or we do not solve. Now if we choose yes, then this branch labeled by no will be So here we have taken an example. Here we can see that the root node is labeled by some condition which we have to check further. Okay, so this condition will be evaluated, and from this root node there are two branches which are coming out. So one branch is labeled by no, another branch is labeled by yes. If we choose no, then we don't serve, and if we choose yes, then this yes decision will go into this internal node labeled by bind. Okay. Now we can make two different decision. So if the low is found to be is the wind is found to be low, then we will surf. Otherwise, if the wind is found to be high, then this decision will go into another internal, which is labeled by wind direction. Okay. Now, if we choose the offshore decision, then we will surf, and if we choose onshore decision, then we don't surf. Okay. So this is a kind of decision tree that we have to make when we solve a classification problem. Okay. So we can solve binary classification problem as well as multi-class classification problems, but most of the cases we use this decision tree for binary class classification problem. Now, decision tree use the divide and conquer strategy by conducting a greedy search. Okay. Now, in order to identify the optimal split point within a tree, we use this divide and conquer strategy by conducting a greedy search. Now, the process of splitting is repeated in a top-down manner. Okay, top-down as well as the recursive manner. Until and unless all the majority of records have been classified under specific class levels. Okay, so we perform this in a repeated manner from top down and from top to down hierarchical manner, and until we continue this splitting process until and unless all the major records have been classified under specific class levels. Okay, so if we have two different class levels, then either one class levels until unless most of the records have been found to be either one class level, so we repeat this splitting process from up to down and recursive manner. So whether or not all data points are classified as Boolean sets is largely dependent on the complexity of the decision tree. Okay, and small trees are more easily able to attain pure leaves, that is the data points in a single class. Okay, so if the tree is found to be very smaller, then we can easily attain the decision, and these lymph nodes will be found to be pure lymph nodes. Okay. So as a tree grows, it becomes increasingly difficult to maintain this purity. Okay. So in case of small trees, it is not a big issue, but when the tree grows in size, then it becomes difficult to maintain this purity, and it usually results in too little data falling in the subtree. Okay. Now here we will look on this slide. We will look the different types of decision tree. In 1960, the Hunt algorithm was developed in order to model human learning in solution, and this forms the foundation of many popular decision tree algorithms such as ID3, C415, CART. Okay, so these are the different variant of decision tree. So each one is having their own advantages and disadvantages. So the first decision algorithm is also known as the which is the term of iterative dichotomizer 3. So here the Ross Milan is developed this ID3 algorithm, and this algorithm uses entropy and information gain as metrics to evaluate candidate speed. Now to split the decision tree or split the tree that we are constructing is used entropy and information gain. So these two are the major tricks by which we can split the evaluated candidate. Okay. Now another ISC 4.5 algorithm is considered a iteration of IDC. Okay, and this was also developed by William. So we can use information gain or gain ratios to evaluate the split points within the decision tree. So just like it also uses information gain or the gain ratios to evaluate the split points in the decision tree. Okay, so where the split to be made, so that will be decided by either the information gain or the next decision tree variant is known as CART. CART is an abbreviation of classification and regression, and it was introduced by Dayman. This algorithm uses Gini impurity. So another method, Gini impurity is used in CART algorithm. So which is used to identify ideal attribute on split on. So what Gini impurity? So Gini impurity measures how often a randomly chosen attribute is misclassified. Okay. So so this is the measures done by Gini impurity. So apart from entropy, information gain ratios, so we can also use the Gini impurity to identify the ideal attribute is freedom. That means among a set of attributes, so which attribute will be found to be ideal, on which we can see the decision. Okay. Now to construct a decision tree based on the evolutions of the root node and internal nodes. So we can define two important terms. One is the entropy, another is information. Now, what is entropy? So entropy is called as Shannon entropy, which is denoted by Hs for a finite set S. Okay, so here S is the entire data set. So S represents the entire data set. Okay, now on the data set we can get the entropy, which is denoted by Hs, and it is the measure of the amount of uncertainty or randomness in data. So entropy measures the amount of uncertainty or randomness in data. Now the entropy is divided by Hs, which is given by the summation over Px log of 1 by Px. So this Px is the probability of the event X, okay, where X belongs to capital X. So capital X, so this means here some attribute or feature in the data set. Okay. It tells us about the predictability of a certain event. So if we want to know the probability of a certain event, then we can use this entropy equation and get the amount of uncertainty or randomness in the given data. For example, I toss a coin whose probability of hits is only 0.5 and probability of tails is 0.5. Okay. Now here the entropy is the highest possible because there is no way to determine what will be the outcome might be. Okay. So what will be the outcome? So that cannot be determined before we toss the coin. Okay. Because the probability of heads is 0.5, probability of tails is 0.5. Okay. Now, in this case, the randomness or uncertainty is found to be very high. Therefore, the entropy will be 1. Okay. Now, if we consider the another case where the coin has heads on both the sides. So in this case, before we toss the coin, we can easily say that when we toss the coin, so every time we will get the head. Okay, because both sides of the coin is found to be head. Therefore, the entropy of such event can be predicted perfectly, since we know beforehand that it will always be head. Okay, so in other words, what we can say, this event has no randomness because the both sides of the coin are found to be heads. Therefore, it is easily predictable. It is easily predictable to it is easily predictable for such an event that what after tossing the coin, so what will be the outcome? Okay, so that is why the randomness is found to be 0 or uncertainty is found to be 0. So therefore, the entropy is also found to be 0. So when we get the perfect uncertainty or randomness, just like the previous case, then the entropy is found to be very high or 1, or when the uncertainty hello, can you hear me? there is a disturbance today. There is a network issue.
Yes, sir, we can hear you.
Yes, you can hear, but there is a disturbance. Okay. So next important term is information gain. What is information gain? So information gain is called as Kullback-Leibler divergence, which is denoted by Ig S, A for a set S. So as I said that S is the entire data set. S represent the entire data set. Okay, and it is the effective change in entropy after deciding on a particular attribute. Now here S represent entire data set and A represent a particular attribute or a feature in the data set. Now this information gain measures the relative change in entropy with respect to independent variables. So independent variables means the instances that we are considering in the data set. Okay. Now here information gain is given by Hs minus H of S comma A. Okay. So we know how to calculate, how to compute the entropy over the entire data set, and this is the entropy for a particular attribute in the data set. Okay. And this H of S comma A is given by summation over probability of event X, which is multiplied with the entropy of event X. Okay. So this is the this is the formulation for information gain. So this information gain measures the relative change in entropy with respect to some independent variable. Okay. Now here entropy here information gain is used to evaluate the root node as well as the internal nodes in order to get the split within the decision tree. Now here Hs is the entropy of the entire set, while the second term calculate the entropy after applying feature A. As I said that this H of S comma A is the entropy after applying feature A or attribute A, and here Px is the probability of event X. Okay. Now let us take an example of a data set. Here you can see that here we have 14 instances. Okay. So here we have 14 instances. That means 14 consecutive days, day 1 to day 14, and these are the corresponding outlook, temperature, humidity, wind for these 14 days. Okay. And here we have to take the decision whether for in a particular day, if the outlook, temperature and humidity and wind is found to be some particular condition, then whether we should play golf or not. Okay. So this is the in this data set, we have two different decisions, two different outcomes. So here the class levels are given for these 14 instances, and here we have 4 attributes. Outlook is one attribute, temperature is another attribute, humidity is another attribute, and here wind is another attribute. That means there are 4 features, and here day 1 to D1 to D14 are the 14 instances. Okay. And play golf is the class. That means here we have 2 different class levels, yes and no. Okay. Now in this data set, here we can see if we consider the day 1. So in the day 1, outlook is found to be sunny. So since this outlook is an attribute of the data set, so here we have three different values of outlook attribute: sunny, overcast, rain. Okay, these three are the different values of the outlook attribute. Similarly, if we consider the temperature attribute, then temperature attribute is having three different values. One is hot, mild, and cool. Okay, and similarly, humidity attribute is having two different values, high and normal. And here wind attribute is having two different values, weak and strong. Okay, so based on this attribute, we have to first compute the information. First, we will compute the entropy of the entire data set. Then we will compute the information gain, and based on the information gain, we have to choose a particular attribute, and that attribute will become the root node of the constructed decision tree. Okay, so that means this data set will be given to you, and from this data set you have to construct a decision tree. And to construct the decision tree, you have to use two different important metrics. One is the entropy, another is information gain. Initially, you will start with the entropy. You have to calculate the entropy of the entire data set. Then you have to compute the information gain and information gain of the different attributes in the data set. And based on the attribute value, you have to choose a particular attribute or particular feature, and that attribute will become the root node. Okay, so this is the idea. Now let us look at the different steps of the ID3 algorithm. So to construct the decision tree, here we are using ID3 algorithm. So what are the different steps of the ID3 algorithm? So first of all, we will create the root node of the tree. Okay, so this is the first step that we have to perform. In the second step, if all examples are found to be positive, then leap node will return positive. Otherwise, the leap node will return negative. Okay, and in the next step, we calculate the entropy of the current state. Okay, and in the next step, for each attribute, we will calculate the entropy with respect to attribute x denoted by age of s comma s x. Okay, then we select the attribute which has maximum value of information gain. As I said that based on the information gain of the attribute values, so the attribute values which will be having the maximum value will become the root node of the constructed decision tree. And then we remove the attribute that offers highest information gain from the set of attributes. And we will repeat this process on the remaining attributes. Since once we get the attribute with maximum value of information gain, so we will remove that attribute from the dataset, and we will have the remaining subset of the database with the remaining attributes, and on that subset of the database we will repeat all this process. Okay, until and unless we run out of all the attributes. Now let us consider that this data set, and we will construct the decision tree. Now first of all, we will compute the entropy of the current state. So in this example, here you can see that how many no class level are found. 1, 2, 3, 4, 5. Okay, so 5 class levels are leveled by no, and 9 class levels are leveled by 9. So we have total 14 decisions, 14 class levels. Okay, now what will be the entropy? So we know the entropy is given by this summation over the probability of event x, which is multiplied with log of 1 by probability of event x. Okay, now we can get the probability on the entire data set which is given by minus 9 by 14. So why 9? Because for the yes outcome, we get 9 by 14 log of 9 by 14 minus 5 by 14 log of 5 by 14. So 5 for the no outcome and 9 for the yes outcome. So this is the entropy. So entropy is found to be 0.940. Okay, 0.940. So this is the value of the entropy. So we can interpret this entropy value that since the entropy value is found to be very high, which is found to be close to 1, therefore the randomness or uncertainty is found to be also very high. Okay, because this entropy value is found to be very close to 1. So one is the upper bound of the entropy, and lower bound of the entropy is 0, and 0.94 is found to be very close to 1. That is why we can conclude that the randomness or uncertainty is found to be very high in the data set. That means the distribution is fairly random. In the next step, we choose the attribute that gives us highest possible information gain. Now, one by one, we are going to choose the attribute and we will compute the information gain. Okay. So information gain for wine attribute. So here we can see the data set. So first we will compute the information gain for wine attribute. Then we will go for humidity, temperature, outlook. Okay. So how it is computed? So here this information gain is given by this equation. So information gain is given by HS. This is the entropy of the entire data set minus summation over probability of event X multiplied by the entropy of event X. So here X is the possible values. So here X represent the possible values of a particular attribute or feature. So here the attribute we have chosen is the wine. So attribute wine takes two possible values, as I shown earlier that wine attribute is having two possible values. One is the weak, another is strong. Okay. Now we have to calculate the entropy of weak. Okay, entropy of strong, then probability of weak, probability of strong, and this is the entropy which has been calculated on the entire data set. Okay, so this is already calculated. So we have computed HS, and now we have to calculate this Px into Hx. Okay, for n number of. So here n is the number of possible values for an attribute. Okay. Now, since we have chosen the wine attribute, so for wine attribute, there are two possible values, weak and strong. And for this, how many weak values are found? 8 weak values, okay, and 6 strong values, total 14 values. So among 14 examples, we have 8 places where the wine is weak and 6 where the wine is strong. Okay, so here we will calculate the probability of weak values. So here the number of weeks is 8. So upon 14, so for strong we will get 6 by 14, and entropy for weak is found to be 6 by 8. Okay, why 8? Because here 8 is the total number of places where wine is found to be weak. Okay, so here we get 6 by 8, 6 by 8, here 2 by 8. Okay, so 2 by 8 means that 6 among 8 weak examples. 6 of them are yes for playing golf, and 2 of them are no for not playing golf. Okay, so therefore here we get the entropy for weak is 0.811, and for strong we get 1. Okay, so here we get 1 means the entropy is found to be highest. Okay, it reaches the upper bound. Okay, that means the randomness is found to be fair, or uncertainty is found to be very fair. So in this case, we will get the information gain for wind attribute is 0.048. Okay, so this is the information gain. This value is found to be the information gain for wind attribute. Now, similarly, we will get the information gain for outlook attribute, for temperature attribute, for humidity attribute, and we have already computed for wind attribute. Now, among these information gain, different 4 information gain values, which is having the maximum value. So for outlook, here we can see this is found to be maximum among uh, among the different attributes in the data set. Okay, so therefore the outlook attribute will become the root node. Okay, so whenever we will compute the information gain for different attributes in the data set, and the attribute which will be having the maximum information gain value, then that attribute will become the root node of the constructed decision tree. Okay, so here we have get the root node which is labeled by outlook attribute, and since the outlook is having 3 different values, sunny, overcast, rain, therefore 3 branches will be coming out from this outlook, from this root node. Okay, 3 branches will be coming out from this root node. Now here we can observe that whenever the outlook is overcast, so we will play golf. So that means the play golf is found to be yes, and it is not a coincidence by any chance. The simple tree resulted because of the highest information gain is given by attribute outlook. Now, if we want to proceed, that we can simply apply the recursion. Okay, recursion means that since we have got the outlook as the root node, therefore we will remove this outlook, remove this outlook attribute from the data set, and the remaining data set that we will use for the computing the information gain for the remaining attributes. Okay, so here we get the subset of the data set. This is the subset of the data set. So in this subset of the data set, here that means since we have 3 branches, sunny, overcast, rain. For sunny, we will get this subset of the data set. For overcast, we will get another subset of the data set in which the outlook attribute is already removed. Okay, and for rain value, we will get another subset of the data set. Now this is for the this subset of the data set is for the sunny value. Okay, so from this subset of the data set, we will again compute the information gain for temperature, humidity, and wind. Okay, so here we get this is the information gain for humidity, temperature, and wind. So here we can see that the information gain for humidity is found to be very high, apart from temperature and wind. Okay, so therefore for this branch, since the sunny is the one of the values of the outlook, so for this branch, here we get the humidity as the internal node. That means the information the branches which is the branch labeled by Sunny coming out from the root node outlook is going into the humidity internal node. Okay, so the internal node, this internal node will be labeled by humidity. Okay, so humidity has two different values, high and normal. Okay, and overcast has already we are having we are having already we are having the level which is yes, and for rain here we get the wind attribute. Okay, that means here we have chosen the wind attribute because wind attribute is having the highest information gain value. So therefore for this branch we are choosing the wind attribute, and from this wind attribute, so from this internal node, two branches are coming out. One is level by strong and other is weak. That means this strong and weak are values of this, two different values of this wind attribute. Okay, so this is the final decision tree. So decision tree will be look like this. So whenever you will be provided a data set for classification, so you have to build a decision tree using a decision tree variant. Okay, and then for some unknown sample, you have to use this constructed decision tree, and you have to reach some outcome. Okay, if it is the binary classification, then if the binary classification is labeled by yes or no, then either you will reach yes or no, depending upon the values of the different attributes. Okay, so this is the entire data set. So if we add one more instance, let's say day 15. So what will be the situation of that day 15? So day 15 will be having the outlook value, temperature value, humidity value, wind value. Now we have to decide whether on day 15 you will play golf or not. Okay, so that is the decision you have to make after constructing the decision tree. So from this entire data set, from the given data set, you have to build up this decision tree, and for some unknown sample, the class label will not be provided. Only the attribute values will be provided for that unknown sample, and then you have to apply the decision on you have to apply the decision on each internal nodes as well as the root node, and based on the evolution of the root node and the internal nodes, you have to reach a decision. If it is a binary classification, then either one yes or no will be your decision, or if it is a multi-classification problem, then there will be more than two decisions will be found. Okay, and accordingly you have to make the decision. Any questions from today's class? If you have any questions from today's class, you can ask me. Okay. So that's all for today. So our next class will be held on coming Monday. I will send the PPTs on SBM and decision tree by today evening. Okay.
Okay. Yes, sir.
Okay.
Thank you,
That's
sir.
all for today.
Thank you, sir.